The most common mechanic added to video games, aside from movement, I think is shooting, and that's what we're going to talk about today. I'm going to go over all of the details of how you shoot in Unity. We'll talk about 2D shooting, 3D shooting, missiles, bullets, lasers, bombs that you can right-click and explode, heat seekers, things that follow the mouse, handling collisions and blowing things up when we hit them, and we'll even go into performance and pooling a little bit later. So if you're interested in shooting or you just want to get better at Unity and see how I put together shooting systems, follow along and hopefully you learn quite a bit. Before we get started though, please make sure to hit that like button or subscribe or share this video. And if you have other suggestions or recommendations for different ways to shoot or tips for shooting that you think everybody else would be interested in or that maybe I could learn from, please share them in a comment below. I'd love to hear them, and I gain a lot of knowledge this way. So does everybody else. We're going to start the shooting tutorial by setting up a simple scene that we can move around a spaceship in. And here I have a scene with just a camera and a background image that looks kind of like outer space. And I'm going to take my player ship and drop this into here. The first thing that you'll need to note when you're working in 2D with bullets or shooting or anything in 2D though, is that you need to make sure your texture type is set to Sprite, 2D, and UI. So you'll select the texture here. I've got this ship, and this ship is actually a sprite sheet full of different textures for my ship so that I can have an animation on it. I'm only going to use the first texture though, but that's what you're seeing down here in the preview. Again, you need to make sure that texture type is set to sprite and then just drop it into the scene. It should show up, and it might be underneath the camera. If it is, I can grab it and just drag and pull it over here. Now it's also showing up behind the background. The reason for this is my order in layer. If I turn the order in layer up, it'll render on top. Things that have a higher order in layer render on top of things that have a lower order in layer. When they match and they both have a 0, which is the default, it's kind of up in the air which one's going to be on top. So maybe it shows up, maybe it doesn't. If it shows up and then stops showing up, make sure you go back and check that order in layer area again. Okay, so we've got a player ship that we can, well, start moving around. Let's set up the movement. To do that, I've created a script. I'm going to go into this scripts folder, and by the way, these scripts are all available for download. If you look down below, there's a link. You can get the entire set of scripts and put them into your project and start using them right away. So let's take a look at the ship movement script. We're going to assign this to our player ship. So I'll select the player ship, and I'm going to rename it. I'll hit F2 and just name this player, or I could go up in here and type player, and then I'm going to assign the ship movement script to it. Now I'm going to hit play, move around with WASD, and then take a look at the script. Let's see what it does and then see how it works. So here I can hit S to go down, W goes up, D goes left, A goes left, D goes right. You get the idea. Very basic movement. We'll open up that script and let's take a quick look at it. We have a couple things going on here. We have a speed variable. We use the serialized field attribute so that it shows up in the inspector like this. We also have an update method where we read the vertical and horizontal axis values. Then we create a new vector 2 using our horizontal and vertical values. So we say movement is a new vector 2 with our horizontal on the X and our vertical on the Y. And then we add the dot normalized. What this is doing is actually creating a vector 2 that has these values and then normalizing it so that the total value of them, or the total magnitude of them, is 1. The reason that we do this is so that when we hit D and W and go diagonal, we're not going faster. If we don't normalize this value, we'll end up getting a speed boost when we move diagonally. And you may have seen that in games before. If you see a speed boost when you're going diagonally, they're probably not normalizing that. Next, we multiply it by time.delta time and our speed so that we can normalize for our frame rate. And then we call transform.translate to just move the object relative to world space. It's important to note that we're using the world space relative value here. If we use the default or self, it's going to move based on its 3D position, and it's going to start moving into the world along the Z-axis. So here's our script. Let's take a quick look at it and see what it's doing. First, we have a bullet prefab that uses this bullet class, and we'll take a peek at that shortly. Then we have a fire delay that gives us an amount of time between each shot that's fired, and it's defaulted to 1/4 of a second. Next, we have a float that's storing the next fire time. This is going to be the time that we can actually shoot our next shot off at, which is going to be using that fire delay. Then we have a Boolean method that returns back true if we're ready to fire and false if we're not. And we do that check just by checking to see if the current time is greater than or equal to the next fire time. A very simple way to do it, an easy, quick timer. Then we have our update method that's called every frame, and here we just check if we're ready to fire, and if we are, we fire. Firing is a very simple process as well. We instantiate the bullet prefab at our position given our current rotation. So remember, we have a child object, so we could rotate it or move it or offset it if we want. And then we set the next fire time, and that's all there is to it. Now, if we wanted to add a delay or a check for a button press, we could also add in another check here and say something like if ready to fire and input.get button and maybe check for fire 1. So it only fires if we're holding down the left button, or maybe fire 2 and it only fire if we're holding down the right button. Or we could do a get button down and have it only fire on clicks. For a shooter game like this though, I'm good with just firing every frame. So let's stick with that. I'm going to delete the check here and we'll move on to the bullet. And here's our bullet script. Now, first I want you to note that I have commented out our collision method, so our damage looks like it's unused. You'll see that used a little bit later. But really all we have here is a self-destruct time and then a start method that's telling it to destroy our game object after that start time. By the way, if you're not familiar with this syntax, it's the expression body method syntax, and it's just useful when you have a single line method. It makes it so that we can have a start method with the one thing that it's doing without 4 lines of code. The alternative is to have it like this as a statement body, but when I have a single thing, I like to shorten it down to an expression body. Now let's set up a bullet. The process for this will be the same for all of our bullets, so we'll just do it once, but we're gonna click on this green bullet here, or whatever bullet texture you have, and make sure that it's set to Sprite 2D, and you should see something similar to this, a little transparent image. I'm gonna take my bullet now and drop it out into the scene, and I've got my green bullet game object selected. And the first thing I'll do is take a look over here in the inspector, and I don't think I need to adjust anything in the sprite render. Well, maybe. Let's turn up the order and layer actually. Let's make sure that that's set to at least 1 so that it's above our background. Now I'm going to collapse that sprite renderer and start talking about other components that we might need. So our little bullet here is going to need to collide with things, so we should probably add a collider. Let's zoom in. And let's add in a collider. For this, we could add in maybe a polygon collider or something, but it's just this little bullet. I think I'm going to go with a circle collider instead. The performance will be a little bit better and it'll just work just as well. I don't really need it to match the exact outline of this thing. Now I can shrink the radius down a little bit and I think that looks pretty good. Let's go to like a point, I'm going to go to 0.08. There we go. So now I've got my collider. The next thing I want to add in is a rigid body 2D. I want this thing to work with physics, and we're using 2D physics. So again, I need to select a 2D component. And I want to disable the gravity scale because I don't want this thing falling down. If I don't do this, it's just going to fall straight down. If I do, it should just stay exactly where it is until I add some force to it. All right, I don't think I need to change anything else in my circle collider or rigid body, so I'll collapse both of those, and I will add my bullet script. Now I've got my bullet script on. Well, I'm almost ready. I could probably set up my game objects and have it spawn. In fact, let's do that. I'll go select my weapon, and I'm just going to assign this green bullet here as the prefab. I did not actually create a prefab. I just assigned the instance here just because I want to hit play, watch what happens. So I hit play, and well, I can move around and just drop these little green things. Pretty cool, but not exactly what I wanted to get to. I want these things to fire off, and I do want to turn this into a prefab. So first, let's turn this into a prefab. And to do that, I'm going to take my green bullet, and I'm just going to drop it into this folder here. Now, I actually have a prefabs folder, so I'm going to go into the prefabs folder, and I'm going to drop it into here. And just ignore these other prefabs for now. These are the pre-built ones that I'm going to show you that I've put together. But for now, we're going to create a new one. We'll take this green bullet, and we'll just drop it right into here. So I've got my bullet in there. Now we'll go back to the weapon, and I want to assign the bullet from here. There's a reason to do this, by the way. We don't really want to assign objects to be spawned from scenes. We almost always want to assign objects to be spawned from the project view. Part of that is because these objects could live across different scenes. Our thing could be destroyed in our scene view, like this bullet here could get destroyed. In fact, it would get destroyed on its own, and then we wouldn't be able to spawn objects. And if changes happen to the thing that's placed in the scene, we don't want to spawn a thing that has those changes in it. We always want to spawn something from the prefab. Now we just need to make our bullet move. To do that, we'll add a new script, and that'll be our move bullet script, which has just a speed variable on it. Let's go take a look at the script. So here we have our speed that we can see, and we have a rigid body that we're caching in awake. So in our awake method, we get the rigid body 2D component. Very important to make sure we get the 2D one. And then we have the update method, which just gets our transforms right direction. So this is the red arrow on our objects. If I go look at my game object and hit W, or you can see that arrow right there, or I hit W, I can see that red arrow right there. It changes color when I hover over it, but that's the right direction. Now imagine when we turn around, we're just going to end up flipping this thing over. It's going to be facing the other way, but it's still going to be that same red arrow will be the direction that we're moving in. So we move towards our right direction times time.delta time times speed, just to smooth out with our frame rate and have an adjustable speed. And then we use rigid body.move position, and here we pass in our current position plus the amount that we want to move. So we're using that 2D rigid body component to move so that we can get collisions and get our callbacks and explode and blow things up. So let's go try it out. First, we'll apply the prefab change. So just drag this over here, hit overrides and apply all, and then drag it back in. We want to make sure that bullet prefab gets updated, because remember, our weapon here is referencing the prefab down here, not the one in the scene. In fact, I should probably just delete this one from the scene so I don't make a mistake there. Then I'll hit play, and let's watch and see as our bullets move. Oh, look at that. Our bullets are flying slowly off to the left. So I'm going to stop playing now and do a little trick here. I'm going to game view and disable my maximize on play. I'm going to hit play again. And then I'm not really sure how fast I want my bullets to be, so I'm going to go select this green bullet prefab and just start cranking up the speed so that new bullets will be faster, and as new bullets spawn, they'll just be quicker and quicker. So 5 seems a little bit faster. I'm thinking maybe like 30. There we go. Look at that. Got some nice quick moving bullets. I think I'll go up to 36. There we go. Cool. Now I've got a weapon that's shooting off bullets really fast, and they're self-destroying. You can see them cleaning themselves up. And watch this. Now I'm going to go to my scene view. I'm not even going to stop playing. I'll go select my weapon, and I'm going to duplicate it, hold control and drag up. Duplicate again, hold control and drag down twice. Now I've got 3 weapons firing off a ton of bullets. Next, we're going to set up something that we can hit with our bullets, because what's the point of shooting if we can't hit anything and blow it up? So to do that, I'm going to take my enemy saucer prefab and I'm going to drop it out here into the scene. And look, it doesn't show up. The reason I'm not seeing it is because my sprite renderer's order and layer is set to 0. So I'm just going to crank that up just like I did before, and now it shows up. I wanted to show that because this happens all the time. People get mixed up with this problem. So don't worry about it if you see that and you struggle with it. It's easy to fix. Now I'll collapse my sprite renderer, because aside from the fact that I've got a spaceship on it, which is just this saucer image here, there's really not much else to see on the sprite renderer. So let's go back to the saucer, collapse that, and take a look at the collider. Our collider here is actually a polygon collider. It makes a lot of sense here. We don't want to go with a circle because, well, our ship isn't circular. So we use a polygon collider 2D, and no changes are made to it. No trigger setting or anything else. Next, we have a rigid body 2D. There are also some scripts, but we're going to take a look at those in a minute. We have a rigid body 2D script here, and the rigid body 2D has simulated on and gravity off. We also freeze the Z rotation. We don't want this thing spinning when it's hit. If it gets hit from the top, we don't want it tipping over. We also freeze the Y position because I don't want it getting knocked up and down. And I didn't freeze the X position just because I thought it was kind of cool when it got knocked back when it was hit. We could, of course, adjust the mass so that it gets knocked back less. You'll see the knockback stuff in action in just a little while, though. Okay, I'm going to collapse the rigid body. We have an audio source here that plays a sound. You'll see how that works in a little bit, but it's just a standard audio source set up with a little impact clip. And then we have that move bullet script. You might be wondering, why is there a move bullet on here? Is this a mistake? Not really. It's just that our move bullet could really move anything. It just moves a game object to its right. Now I've set the speed to -8, so now it moves to the left. Let's hit play and watch that thing move. Oh, there it goes. And if I shoot, notice that my bullets go right through it. There's actually a good reason for this, and it's that when we set up bullets in shootable things, we usually use some layers. In fact, if we go take a look at our enemy saucer, notice that he has his layer set to shootable. And if I go into my prefabs and I look at these bullets here, you might notice that their layer is set to bullet, but this new one that I have is not set to anything. I'm going to change it to bullet, show it in action, and then show how you set that up. So I'm going to select the bullet layer for my green bullet prefab, hit play. Let's watch as my bullets now suddenly hit this guy and knock him backwards. And then let's go look at where that setting is. If you go to edit and then go to project settings, you might have to drag it onto screen if yours pops off screen like mine did. And then go find the physics 2D section. There's physics and physics 2D. Under physics 2D, you should see a layer collision matrix. Down here, you'll see all of the layers that you've created. Now, you're not going to have a shootable layer by default. You're not going to have a bullet layer by default. To create those, you can just select any game object. In fact, I'm going to dock this real quick. Go select a game object like this one right here and hit add layer. This will pop up the layers and tags option, or tags and layers inspector, I guess. Then I can name this like Jason's, and now I've got another layer named Jason's. And notice that this little matrix updates with Jason's here as an option. And now I could just uncheck everything, and if I do it like this, now things that are on Jason's layer only collide with things that are on Jason's layer. Now they would collide with things on the shootable, and now they would collide with bullets. I'm going to uncheck all of those because I don't need a Jason's layer, and I'll just delete that back out. But note again that our shootable and bullet are the only thing that collide. Bullets don't collide with bullets, and shootables don't collide with shootables. So our spaceships can move through each other and our bullets can fly through each other, but they will collide with each other. Now let's talk about dealing damage. There's no point in shooting things if we don't do damage when we hit them. So we have a damage field on our bullet, and we have an on collision enter 2D method that I mentioned was already commented out. So I'm going to expand it out and remove the comments. Now our on collision enter method should work and get called, but I want to talk about how this works and how it's different from a 3D method. When we run this in 3D, the only real difference is we're going to use on collision enter instead of on collision enter 2D, and we'd use a collision instead of a collision 2D. Pretty much the only difference. Other than that, what we care about is the thing that we have hit, and we can get that from the collisions collider property, and then we call get component and try to find the take hits component, which is our script that we're going to take a look at in just a moment. I glossed over it really quickly when we were looking at the spaceship. So our take hits component will either be there or it'll be null. So if we hit something that doesn't have a take hits will be null, and all that will happen is our destroy will get called. This will not get called. This question mark dot actually says, hey, if take hits is not null, if we actually found a take hits object, then call the take hit method on it and pass in the damage. This is just an easy way to do a null check in one line. Instead of saying if take hits is not equal to null, then take hits dot take hit. Less code. So let's take a look at what take hits does. I'm going to hit F12 and go into the definition, and let's look at our script. We've actually got quite a bit going on here. First, we have a health value, and this is just hard coded to 10. Of course, you could set up a variable health with a serialized field and then initialize it on enable or something. Right now we're just assuming that our enemies all have 10 health, and it's just hard coded that way. We have a sprite renderer and an audio source, and we're caching those on awake so that we can do some cool flashing and play a little sound effect when we get hit. Our take hit method, this is the one that we care about. Now it's marked as internal. I'm just going to make that public because it doesn't make a difference, and sometimes that gets confusing. So we've got our take hit method. Don't worry about the internal thing. I should have left that public before. Let's take a look at our take hit method. So our take hit method plays the audio source if it exists. Again, that's the question mark dot doing a null check. And then it starts a coroutine called flash, which will just do a little red flash of our sprite so that we can see that we hit it. And you can see what that does down here. It sets the color to red, waits for 1/10 of a second, and then sets the sprite renderer's color back to white, which is the default. So these are just little extra flash and flare, some cool little effects. The actual work is done right here, where we decrement our health by the amount of damage, and then we check to see if our health got below 0 or equal to 0, and destroy our game object. So we blow up our enemy. Let's go try it out and see if he gets destroyed now. So we've got our layer set up. Got our bullet set up. We've got our enemy. I should be able to shoot him, and after 10 shots, he should blow up. There we go, and our enemy is gone. Now we're going to go over some different bullet types, and to do that I've set up a player here with a bunch of different weapons on them that all just have a different bullet assigned. So here I've got that straight weapon with the bullet straight assigned to it, and next we're going to take a look at the nearest one. This will be something that just goes after the nearest enemy target and goes straight toward them. So I'm going to select my nearest one and just enable it. Notice that the rapid fire script is exactly the same. The only thing I've changed here is the fire delay and the bullet prefab. It's now using this bullet seek nearest. I'm going to save, hit play. We'll take a look at how it works and then see what the code is doing. So here I can move up and down, and you can see that these are just going towards the nearest bad guy, the little purple shots. Once that bad guy is dead, they'll move on to the next one. And as I move, they find whoever the nearest guy is. So let's see how this works. To do that, I'll go find my bullet prefab, this bullet seek nearest, and I'm going to take a look at the components. First, we have a bullet component, the same as all of our other bullets, nothing special, just a damage and a self-destruct time. We have a polygon collider 2D on this one, just because I decided why not, let's go with a polygon. We have our rigid body with all of the default settings except for gravity scale set down to 0. And then we have a seek and a move bullet. Move bullet is still that same script that just moves along the axis right here along our right, so whatever direction we're facing. And then we have the seek script that's doing the actual work of following the nearest target. So let's take a look at how this works. I'm going to zoom in just a little bit. And the first thing that you should see is that right here on line 6, we have a target, a take hits target. So we're finding a thing that can take hits, and somewhere in here, we're going to be caching this as our target. That's what I can tell just from looking at that. Then we have our update method, and here we say if we don't have a target, so if our target is null, we acquire the nearest target. Otherwise, we look at the nearest target, or look at our target. So if we don't have a target, we get a target. If we do have a target, we look at the target. Pretty simple, right? So let's look at acquire nearest target first. Acquire nearest target is actually kind of lazy in the way that it does it. It does not do very smart, intelligent caching or anything fast. It just looks at all of the objects of type take hits that are in the scene, orders them by the distance to them. So it takes the distance of them from our transform to T, which is that object in this list's transform. And then we get back the first one. So we're finding them, finding the closest one, and then returning that and assigning that to target. Now, because we use first or default, the default of take hits or any object that's not, or that's an object, is null. So we could get null if there's no object out there, if we can't find anything to hit at all, or we're going to get back the closest one. The next thing that we do is look at our target. So if we've got a target, we found one, we just get the direction by taking the current position of our target minus our position, and then we call dot normalize it, which is going to change the direction value. It's actually going to modify this vector and set it so that the magnitude is 1, so it's just a direction without the distance. Then we use vector2.signed angle to get the angle between our right direction and the direction that we want to face. And we pass that into quaternion.Euler as the z value and set that as our rotation. And this makes us snap and look directly at the target. By the way, this is pronounced Euler. It's spelled weird. If you know why it's pronounced different and you want to share that with everybody, drop a comment down below and let everybody know. It's one of those weird ones that everybody gets caught up on, and took me forever to accept the weird pronunciation. Now we're going to make a bullet that follows the mouse. To do this, I'm going to first enable my weapon seek mouse and hit play and just show you what it looks like, and then we'll dive into the code. So here I've got this little blue bullet, and notice that it just follows the mouse kind of wherever I go. I can aim down here at this guy and they'll go down here, or I can redirect them here and they all just kind of follow wherever I want them to head. So I'm going to stop playing and let's go take a look at this prefab. I've got my bullet seek mouse and it's got a slightly different image here. That's just the only change on the sprite renderer. Our bullet script is exactly the same. The polygon collider is the same. Our rigid body is the same as all of our other bullets. The only difference that we have is this look at mouse script. So let's go take a peek at it. Notice that it just has this look speed variable. So here we've got a serialized field for a look speed that allows us to change how fast it turns and how fast it looks at things. And we've got our update method that just calls look. Our look method first figures out where our mouse is. We use camera.main.screen to world point. Of course, if you're you're used to cameras, you might know that camera.main is not great for performance, but whatever camera you have, you'll need to use screen to world point. Camera.main will work fine in a default scenario like this. So we use the input.mouse position to figure out where our camera is in the world position. Then we get a direction from our current mouse position to the 2D version of our transform position. So I don't want a direction that has any value in the Z. So what I'm doing here is just forcing it to be a 0. If I cast my transform position as a vector 2, the Z just gets set down to 0 and my direction will be a vector 2 the entire time, and I won't ever have a vector 3 here, which is what I want. I want this to be a vector 2. We normalize that vector 2 so that we just have a direction, and then we get the desired angle by using our vector2.signed angle, using vector2.right as our base and the direction that we have, so we're getting the angle that we want to go to. Next, we're doing a little bit of smoothing. Instead of just setting our rotation to quaternion.Euler of that angle, which is what we do in the seek script, we just do some lerping. So we use quaternion.lerp. We go from our current rotation to the desired rotation, and we just use look speed times time.delta time so we can crank up that look speed and make it turn faster. We could also, of course, use this same lerp in the other seek method if we want. So if you want a heat seeking method that doesn't go directly towards things, just add in a lerp there. So what about bombs? You got a bomb, you want to send it out and have it explode. You want to maybe have some control where the player taps the screen or right clicks or something and makes a thing just go out and kaboom, right? Blow things up. How would we set that up? It's actually very simple and almost exactly the same. You might be noticing a pattern here if you've been following along since the beginning. So I'm going to enable my weapon bomb, and notice that it has a bullet prefab called exploding bomb, which is also a bullet. I'll go select my exploding bomb, and it's got this red little sprite here. The bullet is the same. The polygon collider is the same, the rigid body is the same, and the sprite render just has that one change. One thing that I have modified is the move speed on this. I figured that a bomb should move pretty slow, so I've turned it down to 12. I've also added the explode script, which is referencing an explosion bullet prefab. If I pull this over just a little bit, you can see the full name there. And that's referencing my bullet straight, which is just the one that fires off straight. So let's take a look at it. First we'll play, see it in action, and then we'll go look at the script. So there's my red bomb, and if I right click, look at that, it blew up. And you might have noticed the second one over there blew up too. Let's move so we got them at different heights. There you go, I right click and the little green bullets go flying out. Let's change this around a little bit though. So I've got my exploding bomb. Let's say I want my exploding bomb to send off heat seekers. I'm gonna drag in the heat seeker into my prefab. Watch this. Bam! Now I shoot off heat seekers. Of course, since my heat seekers just go flying directly at the direction, they look kind of stacked on top of each other. So maybe I'll use the seek mouse ones and play with those. Fire it off, and look at that. Every time I right click, I get a whole army of little blue guys. Pretty neat, right? So let's see how this works. First, I'll stop playing, and I'm gonna reset this back to just my straight bullets on my explode script. This is on that exploding bomb. And then I'll go open up the explode script. The explode script is actually really simple. We have a serialized field for our explosion bullet prefab where I just changed out those bullets. We have an update method, and here I check to see if I pressed the fired to button. If I did, I instantiate all of these bullets. So we'll loop through 6 times so I can get that nice little 6 different directions. And then we get a direction using I times 60. So imagine 360 degrees in a circle. We just divide 360 by the number of shots that we want to have. I could have figured this out in the math or had the computer calculate it, but I figured out that, you know, I could divide 360 by 6 and it was 60, and I could just put that value in there and it would give me that nice little pattern. So you can try out different sizes, different numbers, or make it adjustable, make it scale up, make it power up, whatever you want. You may have to calculate it, or you could just multiply. So I instantiate the bullet prefab, and everything else kind of does its own work. The last thing that we do though is destroy the bomb, because once the bomb explodes, we don't want it to just keep floating along, so it just destroys itself. Now let's talk about performance, because while it's cool to have a ton of things firing off here, spawning and destroying game objects constantly can be a big performance problem long term, especially when you're on mobile devices or just not on a really high-end platform. So how do we fix this? Well, the typical solution to this is pooling, and that's what we're going to cover. And I wanted to do this because I think it's an extremely easy thing that people over-engineer and over-complicate and kind of get mixed up with, or avoid because they think, hey, I don't necessarily need this. It's going to be too much work. It's going to make it too hard. Let me show you just how easy it can be. To make this pooled, we can add in something like this pooled game object. Now, there are a bunch of different ways that you can set up pools, so don't think this is the only way. This is just one very simple way that we can add pooling to our game without adding any complexity or very much complexity. So here I have this pooled game object class. Now, I'll go over it step by step, so don't worry if you're not familiar with a specific part or if it looks a little bit confusing. Hopefully it looks easy and understandable by the end of it. The first thing that we have here is a static dictionary of pooled game object as the key and a stack of pooled game object as the value. It's named pools and it's initialized. Let's add a new line here and talk about what this means. So our dictionary is just a collection of things that have a key or a way to look them up. So our pooled game object key means that we're going to use the prefab that has this pooled game object as the key. That's essentially what we're doing with it. We're going to assign each prefab there as one of these keys, and then we'll have a stack, which is essentially a list of things that go in order that we can grab objects out of or put objects into, and these are our pool of those objects. So we'll have a prefab, and for every prefab we'll have this giant stack of these objects, and we'll just take one off the stack when we need it, and when we're done with it we'll put it back on the top of the stack, and then when we want another bullet, we'll just take the top one off that stack. So our dictionary is like the list or segmentation of our little stacks. It's like our table with all of our stacks that are labeled for our different bullets. So we have in here a public static method that returns back a pooled game object, and it's called get, and it takes in a pooled game object as a prefab. I also want to note this static keyword on both of these. All this means is that this method and this instance only exist once for our entire project. So while we might have 1,000 pooled game objects out there, 1,000,000 bullets, there's only one dictionary of pools. Static means, hey, only make one of these for all objects of this type of class, and they all use the same one. They'll also all use this same method, which means that they can't reference things on their game object because it's a static method. It can only reference things that are static in this class. So let's see how it references them and what it does. The first thing it does is it checks to see if our pools, which is that dictionary, contains a key for our prefab. So we say, hey, does our table already have a pile of prefabs for bullets that go straight, or for bombs? If that's false, then we add a new one. So we add it by giving it our key and then creating a new stack of pooled game object. And the stack is just a generic type like a list or an array. It's something that's built into C# and you'll see it used pretty regularly in game development and just regular C# development. So we add it there, and then on line 17 we just get the one that matches our prefab, and we do that by using this little accessor here. This is our pools dictionary, and we're going to get the one that matches our prefab's key. And we just give it the key by putting it in those braces there. Then we have that stack. We check to see if the stack is empty. So if imagine our pile of bullets on our desk is empty, we ran out, then we're going to do the code after it. Otherwise, we'll do something else. So what do we do if it's empty? Well, first we create a new one using instantiate. We just call the standard game object instantiate, give it our prefab, and we get back this instance. Then we register for this disabled event, which you see down here on line 33. This is really the only intelligence on this pooled game object. In that registration, what we do is we add it back onto our stack. In fact, I should have replaced this with just stack.push. So now we push it back into the stack. So whenever our game object is disabled, we'll be adding it to this stack. So imagine we've spawned an object, we've gone through some process, eventually it gets disabled, it goes back onto the stack, and then the next time we call into it, our stack count isn't 0 and we're no longer spawning a new bullet. So we're just returning back the instance of one. And that happens right here on line 26. So if our count isn't 0, we use stack.pop, which just grabs the top one off of our stack. We set it to active because our disabled assumes that we have set our object to not active or disabled. And then we return it. So other than that, the only thing we have here is on line 34, where we have the onDisable method. The reason that we have this is so that we can call into our disabled action or disabled event and fire that adding of the stack.push. Now you might think, hey, why don't we just do stack.push on disable? We could, but then we would have to pass in the stack to this game object, and the stack would need to keep a reference, or the game object, the pooled game object, would need to keep a reference to the stack that it was in and then be able to remove itself from there. So it would work either way. I like using the events this way instead. So how do we actually use this system now? I've set up my pooled game object script. How do I change my bullets to be pooled? The first step is very simple. I go to my bullet script and I change this from mono behavior to pooled game object. And then the next thing I need to do is just replace the instances where I'm destroying my bullet with disabling it. So here I destroy my bullet in onCollisionEnter, and I'll just say disable or game object dot set active false. Pretend I remember how to disable a game object, right? And then in my start, instead of destroying after a self-destruct time, I'll say disable. And then I don't think I even need to pass in any variables. And actually, we'll change this to start coroutine. And then, if I can spell that right, start coroutine, disable. Generate a method for disable, which should have an IEnumerator return type. Add a using statement for it for the import using system.collections.IEnumerator. Pops up at the top, using system.collections. And then we'll say yield return. And we'll just wait for our self-destruct time. So new wait for seconds, our self-destruct time, and then just say game object set active false. Nice and simple. We have that same self-destruct functionality, but there might be other areas where we destroy our game object. So let's go take a quick peek. Yep, here it is, the other spot in our bomb. So when we explode, we also destroy our game object, and here we can just say game object dot set active false. Now we're still not spawning from our pool, so we need to make one last minor change. We go to our rapid fire method, and where we spawn our bullet, instead of instantiating, we'll say var bullet equals, and then we can say game or pooled game object dot get, and then we give it our prefab, the bullet prefab, and then we just need to set it to active. So say bullet dot game object dot set active to true, and set the position to our transform's position and our rotation to the transform's rotation. Say bullet.transform.position equals transform.position, and bullet.transform.rotation equals transform.rotation. Delete out the instantiate, and now we suddenly have a pooled system. Let's go try it out and see what this looks like. So we hit play. And watch as objects just disable and re-enable there. So our scene hierarchy, while it has a lot of objects in it, isn't growing, and objects are just changing to disabled, re-enabled, and getting reused. They're getting cleaned up, they can hit things, they can respawn, I can blow up my bombs, and everything just kind of works. And I don't have the performance downsides of spawning and destroying a ton of game objects constantly. I only spawn up to the amount that I need, and never more than that, and it just kind of works. Now we're going to talk about shooting in 3D. Shooting in 3D isn't much different from shooting in 2D. We just have to use slightly different components and maybe calculate things a little bit differently. But the process of spawning objects and even the pooling is exactly the same. So if you're not sure how to use the pooling or how to add pooling to any of these future parts, just take a look at the 2D pooling section and all of those same concepts will apply. Now I want to start with shooting a cannon because this was the first problem that I had to solve in Unity, and it's just one that kind of sticks with me and was interesting and kind of fun to solve. So let's go take a look at it. I have a cannonball scene set up here with a cannon, a cannonball in it, some ground, and a light. I'm going to hit play, show you how it works, and then I'm going to dig into the code and show you how you can set up your own cannon system. So we'll hit play. And if I click on the ground anywhere, you can see that a cannonball just launches to wherever I click. I'm going to stop playing, and I'm going to go select this cannon game object down here, and I'm going to rename this to launcher. I'm going to hit F2 and name it launcher, because this is where my actual cannon script is. And then I'm going to hit play again, but I'm going to do it without maximize, so I can play with this angle value, show you what it does, and then show you how it actually works. So I'm going to uncheck maximize on play, hit play. click around and kind of watch as it shoots, and then let's crank up this angle to like 80 and notice how it flies way higher. It still lands in the same spot where I clicked, it just adjusts the angle that it flies at. And I can bring this down and it'll go like a really straight shot. In fact, some of these I think they're going so straight they're almost headed down. And I can pull it back up to like a 50, and you get the idea. It makes it a little bit adjustable. So let's go see how this Canon script works. We'll open it up and let's take a look at the top. First, we have a cannonball prefab, and the type here is a rigid body because really all our cannonball cares about is having a rigid body. The way that it's set up, you'll see, doesn't care about any extra script, doesn't need any scripts, just a rigid body. So we have a rigid body, and then we have an angle, and our angle has a range attribute that allows us to slide it between 10 and 80 degrees. Then we have our update method. In the update method, let's just zoom it in a bit. We check to see if the left mouse button is pressed with the get mouse button down on call or button 0, which is left mouse button. So if they've left clicked, we do a raycast into the screen, and we use camera.main.screen point to ray, passing in our input.mouse position. If you don't use main camera, you have another camera, just make sure that you have a way to access your camera from your Canon. Have it cache it in the awake or something. Then we call physics.raycast, and if we hit something, we'll get a value back in our raycast hit info, and we'll call fire cannon at point and give it that point. In fact, one little trick I can do is replace this and clean up my code, because now I can assign a hit info in here without having to pre-declare it. So let's see what fire cannon at point does. Fire cannon at point takes in the vector 3 for where we've clicked, and then it calculates out a ballistics velocity using this ballistic velocity method that takes a point and an angle. So it's going to figure out what the velocity is that we need to apply, and it writes out a spammy little log message here, spawns a prefab, sets its position to our transform position, which is why this is on a child here. Let's go take a look at that real quick. So if I look at my launcher here, it's actually on a child right here so that the cannonball spawns at this position. Another alternative is to have this Canon script maybe on the root and then have a transform that I assign to the Canon script for where I want to spawn it. If I did it that way, then instead of assigning the position to transform.position, I'd say like the fire point or the fire positions transform or fire transform, something like that. I'd give it another name and then I would use that position. But since I didn't do that and I put it on the child, I just put it at the position of this object where the Canon script is, and then I set the velocity. Now the ballistics velocity script or method, I don't think really matters you understanding it. You could go through, you can understand it, you can figure out the math. If you care about it, cool, it's useful. But I'd say most of the time, you're going to figure this out once, you're going to save it off, and you're never going to look at it again. You're probably not going to think about it. In fact, you probably just Google it, find the formula, or you can copy it from here or from my webpage, and then just drop it right in. I don't think you necessarily need to understand the math of it, as long as you know how to launch the thing, and then you can make it so that your angle is adjustable. Now we're going to improve the projectile launching so that it actually lines up with an animation and looks cool. Let's see what that looks like. So I've got my guy here, and watch his hand. Now the shot fires out of his hand, not immediately after I hit the button, but after the animation plays. You can kind of see it maybe in action and watch it line up. It might be kind of hard to tell through a video though. But the idea here is that now it's lined up to an animation, and it's playing an animation instead of just, well, shooting a shot out straight that looks kind of weird. So how do we set this up and time it to line up with an animation? I'm going to show you a real easy way to do it with animation events. So I'll stop playing, and I've made a small change to the projectile launcher script. We've also added in a new script that we'll take a look at in just a moment. Let's take a look at this projectile launcher first. The first thing that's different is that I've added this character animator that's cached in Awake. So in Awake, we get a character animator from the children. It's not at the same level. We cache it, and then we say on hit landed plus equals fire. So we're registering for an on hit landed event and calling our fire method when our hit lands. And the hit landed event is going to fire right when our hand kind of extends to the full point. It's when our impact should hit, or when our shot should fire. The name might not be perfect for it. The other change that we have is in our update. Instead of calling fire here, we just tell our character animator to attack. So let's see what that character animator looks like, what the animation event looks like on the animation and the character controller, and how it all ties together. We'll go into the character animator. I'll hit F12. And here I actually have quite a few things going on. We're going to ignore a couple of these things and just look at the hit stuff, just the hit and the hit landed and the attack. So let's take a quick peek first though at awake. In awake, we're caching our animator, and here I'm caching some other components that you really don't care about. They're not relevant to this example. Just know that I'm caching the animator here. And then in the update, we're doing some other stuff that does not matter. Here's the part that matters, our attack method. This is what we're calling from our projectile launcher. I say character animator dot attack, and we just set the attack trigger on our animator. Now you might go, okay, that's weird. Why are we doing all of this? Well, what's happening is our animator is then going to play off an attack animation, and it's going to give us an animation callback. And that's going to go into this hit method. And I've tagged it with this little comment here just so that I know that, hey, this isn't actually unused like Ryder thinks. It's used by an animation event. When this gets called by that animation event, we call on hit landed dot invoke with the question mark. So that way, if it's not registered for, we don't get a null reference exception, and we'll fire off our hit landed, which comes back into here and calls our fire method. So the last part here is our animation controller, and then, well, the animation event that's calling the hit. So let's take a look at our animator, how we set attack. And if you look here, attack is just this variable that gets kind of assigned. What happens is Ryder wants to do a string to hash and kind of clean it up and cache it so that we have the name there. We could also put attack in quotes here, but Ryder likes to recommend cleaning it up, so I like to clean it up as well. So let's go take a look at that animator now. So if we open up our animator, that's actually on a child here. So remember I said that up here I have my projectile launcher and it's getting a child. That's because my model and my animator and animation are down one level. So is my character animator script. And this is just a normal setup with entities in Unity. I generally have the visual part one level below the actual game object that's controlling things. If you're at the same level though, just remember to change things from get component in children to just get component if your character animator ends up at the same level. Or you could even register for and handle those animation events at the same level if you're doing it that way. So here's the animator that we're using, and you'll see that we have an attack that can be entered from any state just by setting this attack bool. So whenever attack is set, we go into the attack, and for this character it's playing my skeleton mage default attack, which is part of the BitGem collection, by the way. They make great assets. I highly recommend them. Go check them out. So let's see what this attack looks like and how this is working. How am I getting that magic hit callback? If I select this model with my animation on it, and I'm on the animation tab, make sure you're not on rig, models, material or something, go to animation, and I scroll down here, and if I look at events, there's actually a little dot right here, and this event, if I click on it, is named hit. And this is just created by me clicking in an empty area, or clicking the plus, and then dragging it to an empty area, and then giving it a name. So now it's named hit there. That's not probably the right spot. But you might wonder, well, how can I tell where's the right spot? Well, I can take my model, drop it into the preview here, drag this up, and it gets a little bit weird trying to lay things out, but once I get stuff into the right position, I can drag it over to right about here, and I can see that my hit is right here. That's where I've got it lined up, and if I wanted to move it, I could. So I'm going to delete the new event one, go select this other hit, and like I could drag it over to here, and then suddenly the shot would come kind of as I pulled back. Or I could, pull it way over here, and then it would fire when I was way back here and kind of fly off with our hand. In fact, let's just try that out. Let's hit apply, hit play. I'll run in there and we'll see what that difference is. It might actually be cooler because maybe it kind of flies out like I'm pushing it instead of like it's appearing at my hand. Guess we'll try. Nope, that's way worse. So I'll probably revert it back. But now you get the idea, and hopefully you understand that you can put in these animation events wherever you want and then call them in code. The biggest part and the most important thing you need to remember though is that the animator and the script that's listening to it need to be at the same level on the same game object. And the big gotcha is that if you change that animation or somebody puts in a new animation, you need to re-add those animation events, and it's easy to lose those and forget about them. Now it's time to cover laser beams. You may have seen the laser beams in the previous section when I was running by dead guys, but now we're going to do a slightly different beam where I run around and I can hit the square button to shoot a little yellow laser at any enemies that are in range. Notice that I can hit more than one at a time too. So let's see how we would set something like this up. So on our player, we have a laser weapon script. This laser weapon is just responsible for firing the laser beam whenever we hit the fire 1 button. So let's take a look at the laser beam. The laser beam shot prefab here has a line renderer on it and a laser shot script on it. We're going to take a look at both of these components, but first I want to show you just how to make your own laser shot from scratch out of the scene view. To do this, we'll create an empty game object and hit create empty under game object, and I'm going to call this laser shot 2. Then we need to add a component, and this is why I wanted to show this, because we're going to add a line renderer. And you're going to expand it out and you're not going to see anything. Even if you go to your scene view, you can look around and you're just not going to see anything. If you hit F to go to it, you might find this little dot, but it's not going to make a lot of sense because as you try to move it and grab the position, it doesn't actually change. If I hit Control Shift F, it doesn't move the position. The line renderer's positions are actually controlled by this set of positions. Right now our line has 2 positions, just a beginning and an end, and they're both set to 0, 0, 0. The only reason we can see it is because the width of it is set to 1 meter. So to move this, I actually need to change the X value of one of these. Notice that if I drag this out, the bar or the line starts to expand. And if I drag out maybe the Y, we should see it go up. There we go, and I can see where the line's going. So this is kind of weird and a little bit hard to use if you don't know about this. Now we could add in multiple positions or more positions, go up to a 3rd position and maybe drag that one out, and that's how you do like a shape that does a curve or a bend or something. But for our laser, oh, we don't really need that. That's a really weird position too. Let's go like that. There we go, that's a bend. But we don't need 3 positions, we just need 2 for our laser. So I'm going to set positions back down to 2, and I'm going to shrink my width down just a little bit. To change the width, we just grab this bar and drag it down. I'll go to like, I don't know, 0.25-ish, right around there. You can also, by the way, modify this by adding in extra points. So you can grab, click, and there we go, add in points, and then you can have variable width throughout so that it gets fatter in some parts and skinnier in other parts. I want it to be nice and steady though, just kind of thin. So I've got my line renderer here, and now I want to make it look cool. I have a couple options. First off, I could probably just buy an asset pack, and that's where I'm going to end up, is with just a nice material from an asset pack. But another option is to just create my own material. I can right click, hit create, choose a material, and then give it a name like Jason's Bad Particle. And then we'll change the shader to particles, and I'll just choose unlit for now. And then we can assign that on our line renderer. So if I go select my laser shot, on this material section right here, I can assign a material. So, whoops, that's the wrong one. I'll take my bad particle one right there, drop it in, and now I can modify the colors of this thing. So if I gotta go back and select my laser shot. I can go select the color here, this little color drop down here, and this gives me a color option for the beginning of the line and the end of the line. I can also put in multiple points along the way. Let me show you how that works. So I click on the beginning of the line, click the color area, and hit red. Now notice that I've got a red to white gradient. Click on the end of the line, click the color, and maybe go to yellow. Now I've got a red to yellow gradient. The top part allows me to change the alpha, so I can make it more transparent on one side or less transparent on one side. I probably realistically want this thing to be about halfway transparent all the way through. And then I need to check to make sure that my material actually is set up to support transparency. See, I'm not seeing it as transparent in here, so we'll go select this, and oh yes, our rendering mode is set to opaque, so go to a fade or transparent. So there we go, I've got a ugly little laser that I could put between 2 points. Let's put that between the 2 points, make it show up, and then I'll show you how to switch it to a prettier material. So to set this up in code, we've got our laser weapon. I'm going to open this up and take a look at it. Our laser weapon has an update method that checks for button down of fire 1, so it's checking to see if we've left clicked. Then we get all of the colliders in range using the physics overlap sphere method. This is going to do a sphere cast around us, or just a an overlapping sphere around us 5 meters out and give us all of the colliders that are within 5 meters of our position. So essentially think of this as, give me all the colliders within 5 meters of this point. Now we could also add in a layer mask to filter out and only get the objects we care about. It's left that out here because we don't need the extra complexity, but for performance you probably want to consider that. Once we get all of the colliders, we loop through them, and then here I'm just getting the entity component. In this game, an entity is the core level for a thing that can take damage or be hit, so that's what I'm using. Whatever it is in your game is what you would want to use, the thing that essentially takes damage. Now, if nothing takes damage and all you're doing is showing the beam, you might not even need that. You could just use a tag or a layer or something else to verify that the object is the correct one. That's what I'm doing here on line 16, checking to make sure that the entity is the right type of entity, that it's not one of my pets and it's not my player. If that's the case, I continue on and instantiate my laser prefab and then call the fire method on it. And on the fire method, I pass in my transform for the laser weapon, which is also the transform for my player, and the entity that I'm targeting with it. So let's go take a look at how that works, because the real code is inside this laser shot. So I'll hit F12, and here we've got our fire method, but let's take a look at the rest of the class first. Up at the top, we have a serialized field for our damage. It just stores our damage amount, and then an amount of time that we're going to be visible for. And then on line 8, we have a line renderer that's cached on line 10 in awake. So we're getting a line renderer component from our game object here. Then in that fire method, where we're passing in the firing object and the entity, we start with creating a height offset that's 0.5 meter up. The reason for this is so that our laser beams don't end up in our feet. If we just use our entity's position and our target's position or our source player's position, if those are down at the ground in their feet, which is usually the case for characters, then we'd have lasers in our feet. We could also alternatively have points on the character that we mark for this, but for now we're just using an offset. On line 16, we tell the thing that we want to take damage to actually take the damage, and we could move this to the weapon part, but I like to have it in the laser shot so that I can swap out the laser shots or upgrade them and have the damage be variable. The next thing that we do is the important part. On line 17, we set the line renderer's position, or the first position. We set position 0 to our from object position plus the height offset. So this is our player's position plus 0.5 meter up. Then we set the second line renderer position, or index 1, to our target's position plus that height offset. And finally, we call destroy with that delayed visible time of 0.0 or 0.1, so that our laser beam just clears itself up after a tenth of a second, not 0.5 second. Now, if you want, you could also, of course, set this up to just disable and pool, and it would be a lot more performant, but I think that that's an easy conversion for you to make from here. So back in Unity, we just need to attach the laser shot script. So I'll drop that on here, and then I'll go attach it, the laser shot that I've created, to my laser weapon. I'm just going to drag it from the scene for now and hit play, and then we should be able to run around and see my ugly looking laser beam showing up in game. Let's see what that looks like in action. And here we go. You can see I've got my laser going, and it shoots between at least a couple enemies. It is really ugly though, so let me show you what I would do to just change it up and make it a little bit prettier. So let's change out that material here, and I'm just going to hit the material search box and find something a little bit different. Now if I search in my project, I've grabbed a whole bunch of stuff, so I'm going to take this laser circle. Oh, look at that, you can kind of see it in action already, and it looks cool without me doing much work at all, and it's already colored. Now this one came from the unique projectiles asset pack. I'd go check that out. It was a pretty cool pack, but putting that in alone I think is enough to make my particles look cool, or my laser beams look cool, and I don't have to do too much work. Now ideally I'd probably want to get an artist to come in and do something fancy with it once I was ready, but for now I think it looks pretty good. The next type of shooting we'll cover is probably the most commonly used, and that's a ray cast. This is what we do for something like a first-person shooter, where we want to shoot right into the center of the screen, right onto our crosshair. So I've set up a scene here using my movement video example. If you want to get a scene that looks like this, go check that out, talk about how to move around and everything. But what I've added here is a simple little dot using the UI and a single script that allows me to click and shoot and turn things red whenever I shoot at them. So let's see how that works and how you can use this to build out a full shooting system. So the script responsible for all of the shooting is actually just the single raycast shoot script that's on my character. I'm going to stop playing and open up that script and we'll take a quick look. The update method checks to see if I've pressed the left mouse button with the get mouse button down 0, and if I have, it calls the fire method. In fire, we create a ray using the main camera's viewport point to ray, and we give it a new vector 3 that's 0.5 and 0.5. The viewport point to ray accepts a vector 2 that's really a value between 0 and 1 on the X and 0 and 1 on the Y. 0.5 on each is right in the middle of the screen. It's halfway across and halfway up. So we use that to get a ray right into the center of the screen, right where my red dot was on the screen. Then I use debug.drawRay and I give it the origin, the direction, and a color and a duration. This is really just so I can debug it and see it in the scene view, and I'm going to show you what that looks like in just a moment. First, I want to talk about line 17. This is where we do the hard work. We say physics.raycast, tell our physics system to do a raycast. We give it the ray, and then we say, hey, if there's a hit, put the info into this hit info object. And then the final thing we do, if there was a hit, is get the renderer component of the collider that we hit and get the material, set that color to red. Here's where you could do some damage or something else, and we'll get rid of that extra semicolon. But this is where you would extend things out and maybe deal damage, make things die, make things explode, or play a particle just like we've done in the other sections. Let's go take a real quick look though and see what the debug draw ray looks like. So I'm going to jump back into Unity and I'm going to pull my scene view and game view side by side, because this is an important thing to understand and be able to see when you're debugging these. So I'll hit play. And then we'll just click and see that little ray that's popping up right there on the front of my character. That is the ray into the scene. So that's where my shots are going. Now it's kind of hard to tell from this angle, but if I come down here, you can see why it wasn't hitting things. It kind of looked like it was hitting things down there. Well, I'm way far away, way above them if you actually look at the ray here. The final thing I wanted to show in here was the image, which is just an image on a canvas set to red and set to a size of 5 and 5. And that's literally it. It's just a single dot there. All right, so we just covered a ton about shooting. Hopefully it was helpful and you picked up at least a couple new tips. Now I'm gonna have more updates to this along the way, so if you check out the link that's probably down below, you should be able to find an FAQ where I'll answer any questions you've got, maybe from down below in the comments. If you have questions or want to know about other shooting methods, drop those down in the comments too, please. And of course, please don't forget to hit the share button, like, subscribe, all that stuff. And thanks again, bye.